Hello, everyone, and welcome to this session of Beyond Bohm, Science, Order and Creativity, Physics and Metaphysics. I'm James Barbieri, Associate Program Director of the Pari Center, and I will be your host for today. As a host, I'm here to help you throughout the call. Through any problems, feel free to just drop me a message in the chat. Before we begin, I just want to very quickly remind everyone of a couple of Zoom rules for this call. First of all, if you could please turn off your microphone during the presentation, just to ensure a good quality audio. But at the same time, we encourage everyone to turn on the camera, as we believe seeing everyone's faces and reaction creates a nice inclusive education environment. During Q&A and discussion, if you want to ask a question, you can use the raise your hand function on Zoom, which is found at the bottom of your screen under reactions, or physically raise your hand, and if I spot you, I'll call you out. Or if you're feeling shy, just ask your question in the chat. Finally, all sessions are recorded for archival purposes and for you all, and the recording should be available to you 3 days after the event. You should receive the link to the recording, so if you haven't, feel free to just email us and we can help you out. And now we can begin properly. Today I have the privilege of introducing Paavo Pylkkanen. Pavo is a senior lecturer in theoretical philosophy and director at the bachelor's program in philosophy at the University of Helsinki. His main research areas are philosophy of mind, philosophy of physics, and their intersection, and his overall aim of his research is to develop a scientific metaphysics. In 2006, he published his book, Mind, Matter, and the Implicate Order, where he proposed that Bohmian notions such as active information and implicate order provide new ways of approaching key problems in philosophy of mind, such as mental causation and time and consciousness. Today, Pavo will be talking about understanding the nature of reality and consciousness, Bohm's philosophical project. And with that, I'll pass it over to you, Pavo. Welcome.
Thank you. Thanks very much for inviting me. It's great to be here again. Some of you may have been in, we had the consciousness seminar earlier this spring. And so let's see, share screen. July is also the holiday month in Finland. So I'm a little bit, it's a holiday mode. So I'm not like typically office hours and but still I hope this will work out. And so and I guess you can see this one. See the slides, yeah.
Yeah, we
and
can.
So anyway, so this in this title, let me just see if I can. I'm still this one. In the title, I also mentioned this both reality and consciousness, because I think as many of you may have read Bohm's book Wholeness and the Implicate Order, and there in the very beginning he says that his overall aim of his scientific and philosophical work has been to understand the nature of reality in general and consciousness in particular as this kind of undivided whole in flowing movement, which is never complete, but in this unending process of unfoldment. So so of course that kind of reflects, that's the way he kind of describes the project there, and of course that does involve many general philosophical questions, such as the nature of movement, that in our experience we sense movement as this undivided sense of flow, but when we think about it, it's as if we're taking snapshots, more static. Our thoughts seem to produce more static pictures. So of course that kind of connects to the Zeno's paradoxes, but also there is this question of knowledge. I think the second step Bohm would take was to say that maybe our knowledge is also part of reality, because of course we also have the more dualist tradition where on the one hand there's the world and then there's the ego or the subject as a separate entity. But if our self and knowledge is also part of reality, then you get the kind of situation, well, when we say that we know things, then it means that one part of reality can know another part of reality. And of course, that can be puzzling. And I think what Bohm does there is he says that suppose reality is this movement, but then our thought gives us these snapshots. So does it mean that we cannot really know reality as movement? Or might there be some way in which we could actually, in some ways, grasp the movement, and perhaps even understand the movement, reality as movement. So he's raising those kinds of questions, which are they're not actually precisely the kinds of questions that philosophers have been focusing on in the, let's say, 20th century. I mean, they're kind of connected ones, but in some ways, I think Bohm had a fairly particular way of thinking about these issues. And of course, I do remember when I got interested in Bohm, it was first in the context of Krishnamurti, but of course, then I immediately became, this was back in 1980, when I also first met Bohm, but I became, as a, like a fair, young student, interested in things like the implicate order, but it was a bit later, like in the mid 80s, then that I then had the great opportunity to discuss with him quite a lot. That was also when I was doing my PhD to University of Helsinki, late 80s. And we would talk actually quite a lot about these philosophical questions about truth and the correspondence theory of truth and all those kinds of issues, which were partly, of course, coming from my studies in philosophy. And it was clear to me that Bohm was extremely interested in those questions. He didn't necessarily have very many people to talk about those issues, because like when he went to Brockwood Park, then it was focusing more about consciousness and transformation and dialogue. And perhaps with Basil, they were talking other kinds of also philosophical questions, but they might perhaps more connected to this, the physics and the big project they were working on. But I think what Bohm and I were discussing were quite a lot of these sorts of questions that philosophers worry about, and it was very interesting. Actually, I did my master's thesis or master's degree at the University of Sussex in 84-85, and my teacher made me read Karl Popper, and I thought it was so great. It was so clear, and somehow Popper's idea of realism and all those views. And I was actually then I went at the same time. I was meeting Bohm quite regularly. We were organizing a conference together this was in Sussex Country Conference Center. And so, I would meet him quite often just to talk about the conference, but then we would also have other kinds of discussions. And I was actually shocked when I realized that he didn't agree with Popper. I had just learned something that I thought was so clear, so simple, and made a lot of sense. And there was, Bohm had this, and that's I guess that's when I realized that he had fairly also kind of subtle philosophical views, and not at all easy to understand. I also remember when I was in Sussex, I was studying with philosophy of mind with the quite a well-known philosopher Margaret Godin, she did philosophy of AI. And then of course, as a young student, I thought that the professor might want to read something that I'm interested in. So I suggested to her that, why don't you read this? Bohm had written something about mind and matter or whatnot. And I asked, would you like to read it? And she kind of said, well, no, I'm not going to read it. And she said, my good friend, Brian Goodwin, biologist, who knew Bohm and Hiley, Yeah, Brian Goodwin always tells me that I should read Bohm. I tried it, but I can't make any sense of it. And this is a kind of an experience that a lot of people who've tried to read wholeness and to implicate order may have had, that it's sort of somehow felt to be also rather difficult to understand. I think for people who in one way or another have found Bohm's thinking, I think people probably feel they do understand it and can read it. But it's certainly there are some kind of challenges and for example something like, and he in the wholeness and the implicate order, Bohm also has the rheomode, experimenting with the mode of language, and that paper really divides people. Actually a couple of days ago we were having a beer with actually one of Basil and my co-author Ilkka Pättiniemi, a Finnish young philosopher, and he likes a lot of Bohm ideas, but it turned out that he didn't like rheomode at all. So I told him, Ilkka, I think you're smart. I thought you were smart. Read it again, because it actually is a rather interesting experiment he does with language. But those kinds of things with Bohm that philosophers, professional philosophers, don't get the point, and they just think that he's being naive or something like that. It's just, I don't know if they would say that he's being stupid, but so I think there's, in some ways, there is this kind of gap between Bohm's philosophical work and then what a lot of so-called professional philosophers are doing, and that's kind of in some ways very interesting. But for example, about the rheomode, there's a linguist called Maxim Stamenov in Bulgaria, and he thinks that Bohm's rheomode experiment is really unique, that it's the first time in history of linguistics that anybody has done such an experiment on language and tried to learn from language. So it's quite clear that some of Bohm's philosophical work divides the way people respond to it. That many people may be very suspicious and they, oh, it's very difficult and can understand it, but then some see there's really something very, very special here. So that was, of course, a little bit the context for my own work when I was doing my PhD on Bohm's philosophy. But in some sense, I was lucky because my supervisor, well, he was a scientific realist, Ilkka Niiniluoto, quite well-known philosopher of science. But somehow I think he sympathized very much with Bohm's approach. I mean, I think I think there was differences in the sense that Bohm was fairly kind of positive to religion and perhaps even to God in some sense, whereas Niiniluoto was an outspoken atheist in the sense that there was clear that he wouldn't swallow the entire Bohmian package. But I think he did understand that. He did see what Bohm was trying to do, and that, of course, for me was crucial because that's, I was able to do my PhD and somehow even got funding afterwards, and which is actually a very tough thing to do in philosophy, and especially if your topic is not the mainstream topic. But anyway, so that those were, I just wanted to give a little bit of that sort of background, that how we were, the kinds of kinds of questions we were discussing, and sort of well, as I said, some of it was precisely this question of knowledge and reality and process. And then the other project was Cognition, where we also with Bohm, we did write something together. Well, the way the writing went was that he was pretty much dictating the text. I would go home, write commentaries, criticism, and then he would read them, and then he would maybe take some things in, and then he would dictate the paper again. And Basil knows probably how Bohm used to like to work. So but anyway, so that in that project, the title of that project was Cognition as a Movement Toward Coherence. And that was sort of I think there the idea was that when we think about knowledge and cognition, of course, one idea there is that we're just trying to make our ideas so that they correspond to reality in one way or the other. But for various reasons, Bohm felt that not to be sufficient. And he felt that in our life and relationship to the world, other people, there's constantly incoherence that is appearing, and there's nothing we can. There's really not. We can't avoid that. That's inevitable. And if we cannot accept it, that's usually going to be a big problem. But then what he said was that what's possible is a kind of movement toward coherence, and that could be what defines our cognitive processes, our thought processes. Or that could be a very fundamental feature. And coherence here is, of course, in philosophy, there's something known as the coherence theory of truth, where we define truth in terms of that if an idea fits to a system of coherent that's already thought to be correct ideas, then that would give the idea maybe the property of truth, or at least we have good reasons to think that it's correct if it coheres with what we already know and trust. But Bohm felt that he wanted to go deeper and say, he talked about this kind of overall coherence, which includes our state of being, the state of our consciousness. I mean, this would go into the Krishnamurti kind of discussions. And it's also coherence in the more pragmatic sense that our actions, in our actions, we do reach our aims. So this is a sort of project that we were quite intensively discussing and talking about, and even writing. And but then, of course, unfortunately, he then became ill, and then he died in 1992, and that project we didn't sort of finish together. But of course, all of that left me quite a lot. I mean, and of course, the other thing that I was thinking a lot of those times was, of course, then the Bohm theory, which is known as the Bohm Hiley ontological interpretation, and with all those ideas of active information, and which I actually talked about in the consciousness meeting. But anyway, so that's let me see now. I've kind of I've lost everybody. Sorry. In terms of hide video panel. No. I'm sorry, because I can't see anything, not even myself. Maybe I just have to do it like this for a while. No. Where did I put it? Sorry, I need to stop sharing, because there we go. I don't know why everybody disappeared. So I just want to.
Just so you know, Pavo, we're not seeing any slides at the moment. We did see.
No, I stopped sharing, but I hope you did see. But I will share some slides now. I think my first. It was a recollection without slides, which is a proper philosophical way to start.
Of course.
But now I will share some slides. I just lost everything. I mean, lost all video myself. There we go. Now I share again. And so, so what I thought I would perhaps go. Let me see, time-wise, to go a bit more specific and concrete. I thought I would take an example of philosophical issue, which I also mentioned in the abstract, and something that actually Basil and myself and this Ilkka Pattiniemi have done some work. Perhaps in some ways I don't know if we're going beyond Bohm, but at least trying to connect Bohm to central philosophical discussions of today. And so this is the question that has to do with identity and individuality of quantum systems. So I'm kind of changing the topic now. not talking about consciousness or those kinds of issues, but this is more like what we might call scientific metaphysics. And of course, there is this central philosophical question about, are objects individuals with well-defined identity conditions? And so we might say, well, sure. I mean, why not? I mean, but of course, those of you who have studied philosophy know that there are all ways of problematizing that maybe even, here's a bottle, but maybe it's changing all the time. Some atoms, some little things are going in and out, and where is the object, and where are the boundaries, and so on and so forth. I mean, you can take any metaphysics book, and there will be a chapter about this topic. And so, but then there might be also kind of scientific ways of questioning this notion of individuals. And perhaps the greatest challenge comes from quantum and relativity physics. And so ever since the early days of the quantum revolution, the identity and individuality of quantum systems have frequently been called into question. And so, and we could say that there were many of these founding figures of quantum theory, and most notably Bohr, said that it's not possible to describe individual quantum objects and their behavior in the same way as one can in classical physics. So, of course, in classical physics, a paradigmatic example may be something like the billiard ball, and sort of which, for example, we might individuate with that it has a particular color or but especially its spatial location, which is different from another ball. We could have two red balls, but which gives them their individuality is the fact that they occupy different regions of space. But of course, already in quantum mechanics, it already with Bohr, there's a, he would emphasize that we cannot separate the quantum object from the context. And but also other people like Bohm, Heisenberg, while already maybe in the 1920s, 1930s, there became this idea that quantum objects might be
Pavo seems to have frozen. Maybe he'll be back soon. Hi, Pavo. Sorry, you were frozen for a second there.
Okay, but I hope let me see. I'll have to do this again. Let's see if I can share again, if it will let me. Yeah. Here we go. So anyway, you see here is, for example, this Leibniz law. In philosophy, there is this principle of the identity of indiscernibles, which states that no two distinct things exactly resemble each other. And this is understood to mean that no two objects have exactly the same properties. But then in quantum mechanics, it seems that in some situations, particles possess all the same intrinsic and extrinsic properties. And this is in standard quantum mechanics, but people give the example of a pair of electrons orbiting a helium atom. And here you can see that that there is this sort of superposition of either particle 1 spin down, particle 2 spin up, or vice versa. And so so the idea is that there is no property of particle 1 that cannot also be predicted for particle 2. And this might be taken to indicate that these particles are not individuals. Of course, then people, when they thought about it, they realized, well, there's something that separates these particles, which is that if particle 1 has spin down, then the particle 2 has opposite spin up. So there is a kind of relation, is the opposite too. They have the opposite property, but that's called weak discernibility, and it's relational. So somehow it's felt that it's not an intrinsic identity that these things have. So that's an example where people start feeling, well, maybe they are sort of non-individuals in some ways, these quantum objects. And of course, then if you believe that everything is made of quantum objects, then somehow, even though we may think that we're individuals, if you believe that there's some sort of fundamental level, we are grounded in something that are not individuals. And so so that's the let me see if we can hear. Why doesn't it? Where's the resume share? Sorry, I'm little. It's really tricky changing between these things, but let me try again. Going back to this one. So anyway, now this question about whether quantum particles are individuals is also raised by the philosophers James Ladyman and Don Ross in their thought-provoking and important book, Everything Must Go. And they advocate the view that quantum particles are not individuals, or at most are weakly discernible individuals. What I showed you, the example was that these two electrons were weakly discernible. You know, they had the spin is the opposite of the spin of the other, even if we don't know which it is. Now, this for them, this leads to a view they call ontic-structural realism. And here's just a crude statement of this. There's epistemic structural realism and there's ontic-structural realism. And you see the idea here is that, okay, crude statement of ESR is to claim that all we know is the structure of the relations between things and not the things themselves. So for example, in the spin example, we just know that we don't know what the spin is, but we know the structure, that it's the opposite to the other. But then with OSR, there's the claim that there are no things and that structure is all there is. So you see, if we lose the individuals, let's say in quantum mechanics, that we have no individuals, what do we have? Well, we have relations and structures, and then if we do believe that the fundamental reality has to do with that, then this is the view, and this is called radical structuralism by the philosopher Van Fransen. Okay, now let's go into Bohm in this with this background. And of course, as all of you know, probably, then Bohm, of course, emphasized in different ways the holistic features of quantum phenomena. But it does also connect to this question about relations. So, for example, you know that he wrote this textbook, Quantum Theory, in 1951, where he was trying to explicate the Copenhagen interpretation of the so-called usual interpretation of quantum mechanics. Bohm himself thought that he was presenting Niels Bohr's view, but I think he realized later that it was the view he was presenting was closer to Wolfgang Pauli's view. And this is just a kind of historical detail that I think Bohm says that in the discussion with Maurice Wilkins. But anyway, so what does he do there? Well, he characterizes individual quantum objects in strongly relational and contextual terms. And he makes this rather strong statement saying that quantum theory requires us to give up the idea that the electron or any other object has by itself any intrinsic properties at all. Instead, each object should be regarded as something containing only incompletely defined potentialities that are developed when the object interacts with an appropriate system. So you see, for example, let's take the electron and say that typically, of course, in classical physics, what we are interested in is the initial conditions. So we'd like to measure simultaneously both the position of a particle and its momentum, and then we can predict the behavior. But of course, we know in quantum mechanics we can't do that because of the Heisenberg uncertainty principle. And so in this book, the way Bohm, so this is the kind of telling that how does the Bohm think about the electron before we make the measurements? So he's saying that things like position and momentum, they exist as potentialities. which we actualize. But they're also kind of mutually opposing potentialities, because if we can't explicate them both at once, so if we measure position accurately, we know nothing about momentum and vice versa. So this is the idea here, that it's kind of philosophically very interesting view. Let's see. And so anyway, the sorry, I just got this. Just one very quick second. And so we can even come back to this view perhaps, but there's much here that is rather fascinating philosophically, even with this view of potentialities. Of course, this is something that Heisenberg in another way takes up later on with quantum mechanics. I think Heisenberg goes more to Aristotelian notion of potentialities. Bohm has here somewhat different view. I don't know whether Bohm too has this more dialectical, because he's emphasizing this opposing, that they are not just potentialities, they are sort of opposing potentialities. But of course, this is sort of and you see, so whereas the intrinsic properties, what would it mean to have intrinsic properties? Well, it would mean that the electron would have all the time, for example, a well-defined position. But that's not so. And note, Bohm says that any other object, so he's generalizing this not just to quantum mechanics, but he's generalizing it to all objects. So you can see that this is he's really very much in the relational camp. And there are other examples. Of course, you know that then Bohm starts, he started working toward the implicate order in the early 60s, where, as you know, the aim was to develop this kind of underlying theory from which one could derive quantum theory and relativity. And again, this framework, if you look at those early papers which he wrote in the 1960s, there's again quite, this strong structuralist and process-oriented way of understanding those individual quantum systems. And so, for example, he writes in one of these papers, he writes that in this theory, the notion of a separately existing entity simply does not arise. Each entity is conceptually abstracted from a totality of process. With the electron, what actually exists is a structure of underlying elementary processes or linkages, supporting a pattern corresponding to an electron. So, I mean, this is very much, it sounds very much like ontic structural realism, because he's using a fairly strong ontological language there. And there, in some ways, it's almost like everything must go. Now, and of course, then, this is in the book, Wholeness and the Implicate Order, where he kind of republishes those foundations of physics papers from the 1970s. So there, an electron is not a little billiard ball that persists and moves, but it should really more fundamentally be understood as a recurrent stable order of unfoldment in which a certain form undergoing regular changes manifests again and again, but so rapidly that it appears to be in continuous existence. So again, we're kind of replacing the notion of particle in classical physics with the kind of a process, unfolding and enfolding, which, however, is able to produce something that looks like a particle if you you abstract it, or if you, let's say if your time resolution is not too sharp. And of course, there's a similar kind of, I'm just giving these examples, but if you then look at the Bohm and Hiley's 1993, in the last chapter, they discuss quantum field theory, and they emphasize, they're saying how in relativity, movement is really primary. And they say something like the essential qualities of fields exist only in their movement. The notion of a permanently extant entity with a given identity, whether this be a particle or anything else, it has best an approximation holding only in suitable limiting cases. So this is again quite interesting that here one maybe admits, yes, there may be essential qualities, but they're really grounded in movement. So it's not that there are some essential qualities that move. It's not that we have particles with some intrinsic properties that are moving, but rather we have to take movement as some sort of fundamental, or if you have some sort of axiomatic notion here. And that gives rise to these more, what we call particles or fields in a usual sense. Now, but I think as many of you know, I don't know if one can say that there's like a black sheep in the Bohmian herd. I've shown you many examples of more structuralist views in what you call it in throughout the years in Bohm's various writings. But you see, in the paper in the famous hidden variable paper he published in 1952, he had become critical of Bohr's view, which in the book that in 1951 he was still defending. So there was kind of change. He realized another way of looking at quantum mechanics, and at least for a moment he at least changed his view, not necessarily completely, but he did change his view much more toward traditional notion of individuality. And this is just the way Bohm is in his hidden variable paper describing Niels Bohr. And this is in some sense almost like complaining about Bohm, you see, because according to Bohr, we have to give up this idea that an individual system like an electron is a unified and precisely definable whole, all of whose aspects are in a manner of speaking accessible to our conceptual gaze. And then he notes that according to Niels Bohr, the wave function is in no sense a conceptual model of an individual system. It's not in a precise correspondence with the behavior of this system, but only in a statistical correspondence. And of course, this means that for Bohr, the wave function is not describing anything out there. It's more a mathematical algorithm that we can use to calculate the probabilities for what we observe with our macroscopic measuring apparatus, like where the needle is pointing. And that's why it's a statistical correspondence, because typically it only gives us the probabilities. But I mean, it's implicit here that in some ways Bohm thinks it might be a nice thing to have to do something that Bohr says we shouldn't do. And of course, we know Bohm's alternate interpretation. It would actually, in this 52, he would say the wave function of an individual electron is a mathematical representation of an objective real field. I think he says in some way similar to the electromagnetic field, although there are differences. And so what is the Bohm's 1952 individual? It has two aspects. It's a synthesis of a precisely defined particle and a precisely defined psi field which exerts a force on this particle. So now we get the kind of an ontological model of what is the quantum individual. And here is, of course, I'm ashamed to show this. It's Basil's cool slide, but just as a reminder for people. So you can see, it was thought to be impossible to give these kinds of particle trajectories while being consistent with quantum mechanics. But here, the hypothesis is that these individual particles choose one of these trajectories depending on where they come to the system. And it's a trajectory that also gives the individuality. It's, you know, it makes this individual, the fact that the given individual goes over here, makes it, and is at the given location, gives its identity. Of course, then it may have other properties like mass and so on and so forth. But still the there are the individuals, and of course here is then the quantum potential that influences the individual. And of course, you see, if the Bohm theory is a coherent option, it undermines the arguments of those who claim that non-relativistic quantum theory somehow forces us to give up the notion that quantum objects are individuals with well-defined identity conditions. And so, so this is why the Bohm theory is very significant also for philosophers. And actually, it was back in 2012 that we, for example, we noticed that Ladyman and Ross in their book, they dismissed the Bohm theory too quickly. So together with the student Ilkka Pättiniemi and myself, and then we invited Basil to join, we actually then wrote a paper arguing that Ladyman and Ross have been, they were too dismissive. And I think Ladyman, he was in this conference, I think he had agreed that somehow, you know, that they hadn't really looked at the details sufficiently, but that this would be another where Bohm is clearly relevant to metaphysics, because the question about individuality is one of the big metaphysical questions over ages, really, and the Bohm theory is relevant to that. So that's a very specific way in which philosophy, even the future, will, you know, a lot of people write about these things, and including Bohm's theory in this context. There's a guy called Michael Esfeld who has written many papers about this also, and also very nice that he refers to our paper. So we're kind of a little bit in the game. But of course, I mean, now one could say that there's kind of an irony there, because there is a tension between Bohm's 52 theory and much of his own other more anti-individualist work, both before and after 52, because you remember I began by giving those quotes from his quantum theory textbook. This very interesting notion of potentialities and this idea that no object has intrinsic properties. Then we do get the 52 theory where we have a very clear model of an object. And then, of course, later in the later work, we see them, and of course, we could say that given the tension, it's not surprising that Bohm and Hiley have developed the Bohm theory further in their later research. So, of course, I mean, as you know, Basil's work, and I'll say also a little bit about that today. So anyway, I think one could say here that beginning to sum up here is that much of Bohm's work supports the idea that individuals are not metaphysically fundamental in the light of contemporary physics. And so his emphasis on notions such as structural process or order and movement as fundamental in physics suggests that philosophical homo Bohm's and really Hiley's more general approach to physics is in some sort of scientific structuralism that takes movement as fundamental, rather than in a metaphysics that takes individuals as basic. And there again, I would somehow say that they are in this respect close to Ladyman and Ross. And see, we could say that Hiley's recent work on simple geometry can be seen as bringing Bohm's 52 approach closer to scientific structuralism. So it's not that, for example, not even Bohm himself, but especially Basil has not wanted to stay with the 52 ideas, but he has really, and as many of you know, is that ultimately Basil's work leads to this algebraic approach that was initiated by Bohm and Hiley, and it's described in the last chapter of Undivided Universe. And so, so now anyway, so we continuing the summary, we could say that the prospects of individuality in the Bohm theory are stronger than what many modern scientific structuralists imply. And that's what we kind of shown in our paper. And that has suggested there's an underdetermination of metaphysics by physics in non-relativist quantum theory when it comes to the question of individuality. And this is something like people like French and Krause acknowledge. And the underdetermination it's a notion in philosophy of science, and it means that the empirical data, we cannot, that doesn't determine a given theory. So the fact that there is the Bohm theory means that it's possible that quantum objects are individuals. Although a lot of people, the standard interpretation, we can produce the examples like the what I showed to you, where they are just weakly discernible. And but of course, another thing that I want to emphasize here is that the notion of an individual in the Bohm theory, and especially in the Bohm and Hiley's developed account, it's very different from what we would expect from the classical perspective. And here are some ideas from Basil that he may want to then continue when I finish. But Basil has emphasized that although the Bohmian quantum individual has a well-defined energy, that energy is not a local energy. And this is consistent with Niels Bohr's views in two ways. First, as emphasized in Bohm and Hiley, the particle is never separated from the quantum field. It's what Basil would call an invariant feature of the total underlying process. And this would be consistent with Bohr's notion of the impossibility of subdividing quantum phenomena in the sense that the whole experimental arrangement must be taken into account. So there is this wholeness even in Bohm's 52 theory. And secondly, Hiley has suggested that the Bohmian individual is not a localized point-like object. As Bohr remarks, the quantum process is a closed, indivisible phenomenon. The energy is not localized at the point, and what Hiley would say that complementary can be taken to imply that energy transcends space-time. But there is a center of energy, a generalization of the center of mass that can be given a position in space-time, and it's this particle-like center that moves with what can be called the Bohm momentum. So I'm showing here this in a way, in some sense beyond Bohm, and just showing how Basil has developed the Bohmian ideas interesting in a way that is also very interested for philosophy and for metaphysics. That somehow we have like richer options. It's not just a simple Bohm theory, but what I think what Basil is sort of struggling to give us is some sort of richer notion of the question of individuality. And so we could say that these ideas are not consistent with the classical notion of a particle, and can only be given a more comprehensive meaning in terms of something like Bohm's notion of structural process, which really he developed in the 60s. And what we could say is that the overall Bohmian approach to physics does not, from the metaphysical point of view, mean a return to the individual's classical physics, but has instead strongly structuralist features, and the scheme has some relevant similarities to Ladyman Ross ontic structural realism, while there also may be some significant differences. But I think I'll stop there. I think it's sort of 50 minutes is probably enough at this point, and I'll think maybe Basil might want to say something at this point.
Well, thank you so much, Pavo, for that great presentation. You've clearly put forward all the philosophical problems that Bohm tried to bring out with his physics, which is very important and also very, very interesting. So thank you very much, Pavo, for that. So today we don't have Shantina, the chair of this event, but as Pavo said, we've got Basil, who probably has something to say about what has been said today.
Yes, very interesting. Thank you, Pavo, for presenting my views correctly, particularly when you say I am struggling to present a coherent view. I think as I've told you many times, I'm guided very much by the mathematics, and therefore I'm really trying to put into concepts, ideas in terms of words of what is coming out of the mathematics. And this is always very, very difficult. I could beat a retreat and say, all I want to talk about is the mathematics, but then it becomes very sterile. And I think it's very important that we try to get the ideas that the mathematics seem to be hinting at out there for you guys to perhaps bring in your experience in philosophy to make it easier for people like myself to communicate what it is we're trying to struggle to get across. Okay, so where do I start with this presentation? Yesterday, I did present very much some ideas on how we think about movement, how we change from the idea of particles being little billiard balls into something where a particle actually has an extended structure, and that extended structure comprised energy, because I don't know how else to talk about it, and that energy is the individual, but the energy is not point-like. The energy actually extends over a region. And I did give a little picture, the best you can do, of the Gaussian blob that I ended up my talk with giving, showing that you can think of the energy as centered on some mean position, but it actually extended over a region which both Giuseppe Vitiello and I were trying to call, in my case, x and x prime, in his case, x plus and x minus. And this really is to give rise to the way the process is unfolding. The process is unfolding not along the individual line, but it's much more general. It's the mean value that is following the line of those trajectories that you showed again. And that is really where you summarize, this is the individual. But now within that individual, there is a process going on, which is not a local entity. And I back this up with the idea that when the high energy boys look at the structure of a proton, for example, instead of seeing it as just 3 valence quarks, as we thought originally when the idea of quarks was first muted, but we find now that there are only 2% of that proton are valence quarks, and all the rest is this bubbling sea of quark, anti-quark creation and annihilation. So it really is active, so that you really can't pin the thing down in a particular way as we would love to do and play quantum billiards. It doesn't work that way. Okay, but then already I think you can see I'm struggling for words as to how to get this idea across. And again, I think I'm going to talk about some new work that Maurice de Gosson in particular has brought to my attention, which I think is very important and which I didn't mention in my talk at all. And that again stems from another theorem. As you can see, as people who are listening to me yesterday, theorems are very important in punctuating the way you think. And I know theorems are always very suspicious things to look at, because sometimes you put assumptions into the theorems which are wrong. But I don't know how else we can progress. So what is this theorem? This theorem was a rather remarkable theorem. First of all, what we find in the way we describe classical mechanics, for example, is that we can redescribe the position and momentum. We can make transformations on the coordinates of position and momentum. And we can actually turn position into momentum and momentum into position. And we still find the unfolding is exactly the same. So the unfolding is the invariant under change of coordinates. And that's essentially the principle of covariance is summarized in that idea. So we've got to be a little bit careful. What are we actually talking about? Are we talking about P's and Q's as what is actually going on? Or are we using our P's and Q's somehow to let us find what the invariants of the movement are, and then it's the invariance of the movement that are, if you like, the real things. So it's not the particle with a position of momentum moving, it's rather with these variables, we can construct an object, let's call it an object, which has not a precise definition as a point, but rather an extended structure, so that the energy that's involved in that process or that particle is actually not localized as a point. And that's essentially what I mean by non-local energy. But I also get the non-local energy from many of my discussions with or reading of Roger Penrose's ideas, that he is very clear that even in the classical domain, it is not easy to see what you mean by a particle. How do you distinguish the particle from the void? And in the last slide I think I gave yesterday, excuse me if my memory is not very good now, but I think what I showed was the London's work. I don't think you know about this paper, Pavo. I don't know whether I sent it to you, but I discovered a 1927 paper by Fritz London, who was really one of the guys who gave us liquid helium and superconductivity. He was in on the early days when he was establishing those ideas. And there he shows that with, and what I did was to show how the Bohm theory actually supports his idea that it is not possible to distinguish between the material substance and the void. There was some sort of, and that's what I said, that's the way I'm trying to talk about, is the blob, because that seems to be a way of indicating something which is not very precise, because I don't think things have to be precise. And I'm wondering whether if we really had the classical world as we would like it, it would be a dead world in which no evolution is possible, no movement is possible. Because remember, go back to Zeno. Zeno was very worried, how on earth do we understand giving a particle a position and yet giving it a momentum, giving it a velocity at the same time? Now, what we did in our in our mathematics was to say, okay, well, we can define the velocity as the difference in 2 points divided by the time it takes to straddle those 2 points. And then what we find is that, and London brings this out in that paper very, very well. This is 1927. And this is where I think Dirac got his idea of unfolding, enfolding, because he has it in his book as well. And I think David Bohm picked that up and developed it in his particular way to show that these are not Emmett railway lines that the particle is chugging along. It is an actual unfolding process. Now, how do you keep the damn thing together? If you've got this vague idea that you've got the derivative is no longer continuous along these trajectories, Bohm makes them continuous by a very subtle averaging process. But how do we keep the thing together if it's more like something like a fractal movement or a Brownian motion movement that is actually the underlying process? What one finds, and this is the theorem I'm struggling to get over across to you, and that is the idea of the no squeezing theorem, Gromov's no squeezing theorem. Now that actually tells us that if you start off with something which is ambiguous in P and Q, so we start off with a blob with a certain size, under Hamiltonian dynamics, under Heisenberg's dynamics, you can never change, under Hamilton's dynamics, under Hamilton's dynamics, that's classical mechanics, that volume, that blob volume in P and Q, delta P and delta Q, cannot be shrunk purely under Hamilton's equations of motion. Once you've made this ambiguous start with your system, the blob, you can never change the size of that blob. Okay, so it goes through in a way which is totally foreign to classical physics. And this is a theorem in classical physics, please. And it's tied up with the symplectic structure that you kindly allowed me to introduce here. It's not the rotation group, because we're all very familiar with rotation groups, because we know that as we turn, we can add 2 rotations to get a bigger rotation and so on. We know all the group properties because we intuitively feel it. But the transformation is much more subtle. It's what the classical physicists used to call the canonical transformations. But the canonical transformations have this property of the no squeezing theorem in there. So that already you've got a sort of a footprint of the uncertainty principle in classical physics. So it's already there contained in the unfolding movement of classical physics. And this, I think, is very important to realize. And in fact, if you follow this theory through, what you find is that to get classical physics, you have to start with your P and Q, delta X, delta position, delta momentum, delta velocity as a point. But if you do that, you then find your theory completely blows up. There's an absolute singularity when h bar goes to 0. So you cannot reach classical physics in just saying, oh, let h bar goes to 0, as many papers seem to suggest. No problem. There's a hell of a problem. The whole thing blows up. And this is proved very nicely by Walter Schempp. Did you ever meet Walter Schempp? You probably heard me talking about him.
Yeah, sure. And I think it may have been in some conference. And I think he also worked with this phase conjugate resonance imaging and things like that.
That's right. That's right. So he's very much, in fact, into the brain, because he thought that this particular feature I'm talking about was very relevant to the brain problem. Okay, so we need the squeezing, the no squeezing theorem to come in. And then we begin to see a lot of the things that I was talking about yesterday become a little bit more reasonable. So you have already built into classical physics, if you like, a kind of unity, an extended unity, an individual which remains, but not an individual at a point. Okay, well, I think I don't know whether that helps, but that's links up with what I was talking about yesterday.
Well, I think that is very interesting in the sense that I actually don't know how much the philosophers who are interested in this question of identity and indiscernibility have been looking into classical physics, but that might be actually a very interesting research area, at least to check it out. That because the discussion has been so much focusing on quantum mechanics, but I think it would add a richer.
Yeah, but can I add the wrong quantum mechanics? You see,
right,
because the quantum mechanics I'm talking about, I'm sorry, is not the wave function plays no role in the new quantum mechanics I'm talking about. The wave function is an algorithm, as Bohr said. So here's me violently disagreeing with Bohr on one hand, and yet supporting him on the other hand. And I think what has gone wrong, particularly in the field of philosophers you mix with, is to try to think of the wave function as something ontic. Right. And it isn't something ontic. And if you do, that's why we have all these problems, this almost a century, and we're still trying to solve the problem of the collapse of the wave function. There is no wave function to collapse. And the reason why the wave function has this subjective objective feature in there is because it is an algorithm. Because we're not following the dynamics in the mathematical sense. We're following an image of it. And I made this clear yesterday, Pavo. I'm sorry you were not able to go, but I understand weddings are much more important than what I'm talking about. But in that talk, this is what I was trying to get across. That it's the process is already in the algebra. And we've got to, you philosophers, I'm sorry, have got to help me in trying to understand what this algebra is actually telling us in the metaphysical sense.
Yes, but of course, it's an interesting question why the wave function has been so tempting, and I guess part of it was, I think, in the early days when Heisenberg first came up with quantum mechanics, then there was not, the wave function wasn't important in that at that stage. But then when once Schrödinger produced his equation and the wave function, then I guess many people felt that gave some intuitive. It was better in an intuitive sense, maybe satisfying our perhaps traditional commitments, and so it may have been that at least there was a period when people felt that the wave function was helpful.
Oh yeah, look, please don't get me wrong. It's not helpful. The question is, what role is it playing? Is it just playing a role which enables us to do our calculations quicker and easier?
No, but I mean, we talked about that before, but for example, if you take something like the two-slit experiment, then you get an intuition in the sense that you put in your boundary conditions, into the Schrödinger equation, and then you get your wave function as a solution, and then you can there predict physical phenomena which look like wave phenomena, interference patterns. So there's this whole notion that the experimental data seems, it's at least consistent with wave behavior, and then we have a mathematics of wave functions which help, correctly predict those wave-like physical phenomena. So I guess that's one of the reasons why people do feel that the wave function is not merely an algorithm, but it does have also some sort of physical, it can be given some kind of physical interpretation.
Okay, then you have the problem that Schrödinger himself drew attention to, the ruddy Schrödinger cat. If you apply the wave function to macroscopic objects like the cat, without knowing why you cannot do it, then you run into trouble of, is the cat alive or is it dead?
But then comes the Bohm theory, and it's like, interesting talking with Penrose. Then Penrose says that, with the Bohm theory, you can solve the Schrödinger cat paradox because the particle will do that. And I remember talking with Penrose, he says that, I asked him about the Bohm theory, and he says, well, that's the way you should do it. The Bohm theory is the way to do it if you want to be with quantum mechanics. And then he adds, however, I want to go beyond.
Yeah,
but I mean,
Pavo, what I'm doing is I'm saying, okay, the first part of the Bohm theory, the 52 paper, does it. But then when we look closer, and I'm not taking this as just me looking, David Bohm and I had many, many discussions. We were in rooms across a corridor for 32 years. And he would always come in my room and we would discuss, and he would take me through a journey, an intellectual journey, which has been a privilege to be part of. I only wish I could have remembered everything that we went through, but it doesn't work like that. So what I'm saying is not that the wave function is not helpful. What I'm saying is that if you want to understand the Bohm 52 paper, you have to go deeper, and you have to go into the non-commutative algebraic structure I'm talking about, because that's the only way you can begin to include things like the Gromov theorem, things like the Stone von Neumann theorem, those big theorems, which as far as I'm concerned, they are absolutely valid so far. And that is the difficulty. But then, you know, the problem has been with the Bohm theory, and this is probably why I'm a little bit, I get a little bit cross. I'm not really cross, you know, I just get excited with the ordinary Bohm theory. And that is because they believe it's got something to do with hidden variables. Now, how often do I have to scream, it has got nothing to do with hidden variables? That is an interpretation that you guys have put on it. And I pointed out that earlier paper. Sorry?
Bohm himself used the term, but then I guess regretted it.
No, but we don't know why he used the term, because I didn't discover the first draft of his 52 paper, which didn't have the words hidden variables anywhere in the title. And I only wish he'd published it in that form, and we would have saved 25 years of argument. I'm sorry to be a little bit angry about, no, you know what I mean. I think, I don't know how to get this across. We've got to drop this idea that it's got anything to do with hidden variables, even the 52 paper, because it's, as I showed yesterday, it's simply a unitary equivalent picture to the Schrödinger picture. And I stick by that.
I guess then the Bohm would say that it's the wave function that's hidden.
That's what you could certainly say that. Yeah, you could certainly say that. But I don't want to, you see, because I know where the parameters are that contains the information that physicists take out of the wave function. It's already in the algebra itself. And Dirac knew this. And Dirac introduced this idea of the standard ket and the standard bra, which I've talked to you about. But many people say, oh, but that's just a ket. No, it's not the ket. It's the ket without the line in front of it. And that means something totally different. It's a basic way of taking the identity and dividing it into its sub-entities, taking the whole and peeling the orange and seeing what's inside that orange. And what's inside that orange is the individual. I'm not saying the individual is an orange, please, but it's got a structure and there is stuff inside there. And I think with our experiments that we are looking at the moment, unfortunately, I was hoping by this stage, I was hoping last summer, that we'd have the results of our experiments where we're actually looking at the effects of this internal structure that I'm talking about. But we've been locked out of the laboratory for a year. And one of our research students has moved on now because, you know, like everything, money seems to be a problem. So we've now got the experiment he was doing didn't quite reach this idea where we could actually get experimental information. These are the weak values that we talked about some time ago, where you get typical effects which you can actually see in the interference fringes, which we've been trying to get hold of. I mean, do you mind if I say something about that, or
yeah,
or do you want to?
Please, no.
I want to hold that I had yesterday.
No.
Is that all right, James?
Sure, if it's quick, just because we should move to Q&A.
Yeah, you've got to have questions. Yeah, I won't go on that. I'll stop, James. I think we ought to go to questions.
Rob, this has been really, really interesting back and forth. I wish it could go on for longer.
There are people waiting.
Yeah. So yes, we'll open it up to everyone else now. You can use the raise your hand function on Zoom in the reactions at the bottom of your screen, physically raise your hand, or write your question in the chat. I can already see we've got hands up already, so we'll go for Mike, who's not showing his camera.
Unmute, start video. Okay, we okay? Okay, so I feel I've been attending a seance with Kant and Hegel. Bohm being the Kantian, or the other way around, Bohr being the Kantian, and Hegel being Bohm. In that sense, I think I'll speak about Kant and the relationship to the form of knowledge that we're working with, which is science. And Kant famously said, "We cannot know the thing in itself," and that's a kind of epistemological limit that Bohr translates into language. We can only know what we can say in that sense. I think that the problem is that, from Heisenberg on, gradually the distinction between the knower and the known, the perceived and the perceiver, has kind of come together in a way that's transformative, and at the same time leaves the chastity of scientific observation and thought, kind of in the ditch. So that whatever we do and think on this level is also influencing the reality. And how far that can be called science is another question. Then on the Hegel side of things, we have the dynamic of relational structures. And I think we can say something about Bohm here, because if we look at Buddhism, which he was quite aware of, the interdependence of the individuals, all individuals, on one another throughout the universe is what gives us individuality in that sense. But beneath that, Bohm is saying there is emptiness, and that has not been mentioned, except very briefly. Basil mentioned the void. And Bohm had those two things. He had the structural relationship giving rise to the network of individuals, but beneath that, that's something else. He had the void. Also, beneath that as well, when Basil is talking about invariance, I'm going to suggest that he suggests that the invariance is time, and that Basil referred to his theory of moments here. Maybe that has some value. In terms of the question of the wave function, we tend to get highly theoretical here and withdrawn from the practice of life. Wave function collapse, you can translate as making a decision and moving. And reality will change with that, whatever decision you make, because you collapse the possibility into one in making the decision. That's a feature of reality which turns up. It simply turns up. And I'm going to suggest that one of the things there that has great meaning is Bohm's notion of a hollow movement. Whether we have, I don't think we do have, in a certain sense, a kind of decision-making in hollow movement that's the same as we do in let's say, our ordinary mind. The hollow movement things, the knowledge does accompany the movement, which is a problem that I think you brought up, Pavo. That the knowing and the movement are fused in that type of action. And I'm going to suggest, again, philosophically, a good read here would be Bergson and Duret, and what he calls intuition, which is a kind of superordinate instinct in a way. And no one mentions Bergson in this context, but he may have intentionally been intending to bridge between Kant and Hegel. And the notion of hollow movement, I think, would tend to do the same thing here. And those are what comes to mind in reaction to what you two are saying. And I'll just leave it at that and ask you to comment. Thank you.
Pavo?
I agree that, of course, Bergson is very interesting here, and some of the other things, but I don't think I have a specific comments on. Maybe Basil, you had some.
No, I don't think so. I mean, I have certainly, we spent a good deal of time talking about Bergson, Bohm and I. So I'm sorry we didn't mention him, but there are so many people who have influenced me over the years, and Bergson certainly was one of them.
Okay.
You always have to pick up your favorite, and I think Schelling for me was the man who really helped me.
Okay.
Thank you, Mike, for your contribution. The next question will come from Claudia.
I try to speak in English this time, okay? And a little bit of patience because we are not able to speak in this language. So I understand a question to Basil and the professor and Pavo. I understand that the similarity, no, the difference, one difference between Bohr and Bohm is the fact that David Bohm gives reality in 1952 to the wave function, while Bohr gives to this tool no a real existence, is just a mathematical tool. So, but after the decomposition of Schrödinger equation by David Bohm gives to the wave function a status of superfluous. Is not there is no need more to give a reality to this to this entity, because the wave function first Bohm considers a reality field. There is an existence, a physical existence. Now, after in the I think several years after, now the decomposition of a Schrödinger equation gives a kind of reality to the quantum potential. Quantum potential as we can consider this level of the quantum potential a level of reality, of a real physical existence, but underlying the world in which we live, in the macro world, but a level of a different kind of reality. Maybe we have now, still not yet the mind instruments to understand this kind of reality. This kind of reality maybe can be considered like a kind of inexistence respect of our level in which we live. There is, but I would understand what is the junction between these two levels. We are just a temporary manifestation of an underlying level, not to be considered as static, but in a dynamic permanence. I don't know if I...
That's good.
Very, un gran casino. Non tradurre, James, perché è meglio. Excuse me, for me, English is very difficult, but okay, thank you.
For me, Italian is impossible.
Okay.
So I forgive you.
Grazie. Thank you.
Pavo and Basil, did you want to comment on Claudia's discussion?
Yes, I think I agree with her. If I've understood what she's trying to say there, particularly at the end. But we were faced in the early 60s with a principle of complementarity.
Yes, yes.
And
yes.
that was somehow saying that it was impossible, in principle, to develop new concepts with which we could understand or try to understand this deeper level. That's what I picked up when I started this, and I thought, no, I don't believe you. Because at any stage, you can always say, we've reached the limit of rationality. And I think Pauli had that idea that we have to have this sort of chaotic, we can't see what lies under quantum mechanics because we'd reached the limit of rationality. So these are the 2 points. Pauli and Bohr, both advocates of the standard quantum mechanics. And I just felt, sorry, mate, I don't believe you. And I'm going to do...
We have to find another instrument beyond the rationality.
Well, but that was what... Yeah, but that was what Bohr was what I thought Bohr was denying us.
Yes, but Bohr, no. Okay, yes, because Bohr, and I think the scientist, quantum mechanics, as for Bohr presentation, is much conservative.
No.
Yes, is much
I agree. No, I agree. I agree.
Much conservative. There is, I think that the Bohm philosophy, the Bohm presentation, is a kind of very similar to a Gnostic system. There is the multi-dimensional reality involved. Just we are. I don't know. Scusami, James. Scusa, mi puoi tradurre questa frase? Cioè, una cosa è dire non c'è individualità nella meccanica quantistica perché io posso considerare solo il sistema, osservatore più osservato, ma sotto non c'è nulla. C'è solo quello, ok? E questa è una cosa, ma Bohm non dice questo.
Okay, so basically, sentence was a bit long, sorry. So basically, there's no individualism in the quantum mechanics because you have to take in consideration the context.
Okay.
And under the context, there's no...
Esatto, the context is represents just a one level, horizontal level of reality, okay? The system observed plus observer, okay? But Bohm says that is another level, binded to the level of the same system. There is another level. The quantum potential is another level. Yep. But the kind of existence is different from the type, the way in which we consider the reality and the existence is another kind of existence, is another kind of reality, but there is, it exists.
Yeah, and I agree. And my feeble attempts are trying to put a face on it, to see what it looks like, to see how we can analyze it, to see how we can penetrate into it.
Scusate, ma l'inglese per me è un disastro.
Pavo.
Thank you, Claudia, anyway, for this discussion. We should really move on now. We'll take the next question from Steve.
Thank you. I've been trying to understand consciousness and to a certain extent quantum theory now for the better part of 50 years. And as you can see, I've got skid marks on my head as a result for the most part, because a lot of this just bounces off and doesn't stick. And Basil's lecture yesterday really got me to thinking that this is a big set of clues on tying these things together in a meaningful way. And I'd just like to know if your slides are available for further study, or if they're put together into a paper, or are you writing a version of this at some point that is suitable for mere math mortals?
My slides have already been sent to Eleanor. So would you negotiate with her?
Oh, yes. So we basically will send out the slides with the recording.
Great.
Okay, but I am, it is my intention to write these up, but I find writing very difficult. And as I write, my mind changes. I don't have Bohm's skill of somehow keeping to a topic and ignoring all these horrible questions. Are you sure you're right? Are you sure you're right? Are you sure you're right? David Bohm didn't have that. He just went straight. I admired him for that. And I'm afraid I can't copy him. I'm no David Bohm.
I understand that problem. Thank you very much.
Thank you, Steve. We'll take the next question from John Briggs. Hello, John. Great to have you. If you could just please unmute.
Thank you. It's great to be here, and I love the exchange that's going back and forth. I hope I can express a cluster of thoughts that they came up in the discussion and these questions that followed. Maybe start with I'm hoping that Pavo and Basil can go a little more into the question of what is reality. I remember at some meeting or other where Bohm was talking that he referred to the Latin root of reality, res, as thing. And it seems to me that when we use the word reality and with that root in it, we're always sort of tethered to the thingness that it implies. Now, I know that Einstein said something like his definition of reality was that's what science is trying to figure out, what is real. Now that's a different take on reality. Somehow in my mind that's related to Basil's blobs, which I thoroughly enjoyed and I think is a wonderful image. You were puzzled by why Bohmian mechanics, which by the way, every time I pick up new scientists and see a reference to Bohmian mechanics, it's like a little shock goes through me because it seems like a contradiction in terms. And you wonder why he gets stuck with that expression. And I know conversations that I've had with scientists over the years that it always comes up to that. It always comes back to the hidden variables are things. And it's the thingness of not only science, but our whole way of thinking is bounded by the assumption that what we're dealing with in the world are things. So I think that's part of the difficulty. I also remember Bohm used to emphasize what he called nothingness or no thingness, which seems to be a useful concept. But all of this is that Pavo and Basil are talking about seems trying to break out of this context that we have created, over the last 10,000 years of viewing the world as made of things and concepts as things. And it ties down language. It's the rheomode, it seems to me, was Bohm's attempt to do something like what Native American or indigenous languages do, which is to prioritize relationship and not to get caught up in things and to see, as Little Bear says, the world as flux. And he's adopted Bohm's idea of the holoflux. So all of that's sort of floating around in a cloud around my head. But the key question I'd like to ask is, can you say more about how you're using the term reality?
Well, I guess, of course, in philosophy, the big question is whether there exists reality independently of the human mind. So that's how usually. So, for example, there's a view called realism or scientific realism, and that's usually defined by. You could see that as there are two theses. There's the ontological thesis, which is a thesis that there exists a reality independently of the human mind. And then there is an epistemic thesis, realism as an epistemic thesis, which is that we can have knowledge of a reality that is independent of the human mind. And so now, for example, Immanuel Kant would then, because Kant, insofar as Kant assumes that there exist things in themselves, Kant would accept the realism as an ontological thesis. But then when Kant says that we can have no knowledge about those things themselves, he denies realism as an epistemic thesis. So these are just some of the basic distinctions that we, like in philosophy, we would start with when discussing reality. And then, but then of course, then there can be. So of course, in some ways, if you are a Kantian, then you can't say anything about the mind-independent reality as it is. So therefore, it becomes more discussion of phenomena, and it becomes more a focus on how the human mind constructs a phenomena. So we have our space and time, the forms of perception, and then we have our categories of understanding. And somehow what we are dealing with is actually something very much that we have constructed, the world of phenomena. But of course, then there are scientific realists that would actually think that science does tell us something about reality, even as it is itself. And this is interestingly, of course, it's something that Bohm was also, of course, sort of struggling with. And I remember then when Bohm and Hiley were writing the Undivided Universe, and I was in London at the time. I think it may have been 91, maybe 91 spring. something like that. And I was then reading also the manuscript, and then in one of the chapters, they do discuss, and it was probably Bohm, maybe Bohm was more responsible for writing those parts. So what, you know, but anyway, they were discussing this question about appearance and essence, and actually saying that in the end everything is an appearance. So for example, when you see a table, you look at it on the side, it looks one way, but then it appears to be one way, and then you look at it from above, you see it as a circle, but then you go in and look at the atoms and say that the table itself was like an appearance and the essence is the atoms. But then you look at the atoms and you see actually they have an inner structure. So the atom is an appearance and the essence, and this seems to be going on endlessly. So then somehow Bohm was kind of following that route and saying that everything was an appearance. So then I asked him, so if everything is an appearance, what's the point of making an ontological interpretation? He had just decided that he wants to have the subtitle of the book as an ontological interpretation. And so he did it then at that point. He agreed then that, okay, that our theories do give a correct description of a certain level of reality. So I think he was backing, in some ways, he still wanted to acknowledge that our theories, there's a sense in which theories can also describe reality, but not as absolutely true, but he would use the term correct, like a weaker notion to say that we can have correct ideas of reality. But I think it's an interesting thing with Bohm. I think if you want to understand him as a thinker, as a philosopher, you can actually see that he was often almost developing with opposite themes. I think we could see it today with the question of individuality. We could see that many places he was clearly promoting this more structuralist relational view. But however, when he came up with when he discovered or rediscovered the 52 theory, it's clearly that he was fascinated by the possibility of producing this model. So in a way, he was in some ways the critic of his own other ideas. And I think in the same way, if you look at this question of reality, on the one hand, he had a strong urge to go beyond Niels Bohr. He had a strong urge to give us models of reality. But then there were these other more philosophical discussions where he would kind of take the ground under his feet of some of the other work. And that's kind of interesting. It's also showing that Bohm was not stuck with any particular view in the sense that perhaps sometimes people are, but he was happy to take up those ideas and see where they would lead him. And he would easily end up, and this is, of course, can be extremely confusing for people who don't have, let's say, a philosophical background or science background, because then you read one thing here and you read the other thing here, and these are the opposite. And then you wonder what you see, what does he say? Well, he's really exploring. Mm-hmm. He's exploring these questions, and in some way just showing that. And this is what I think everybody who enters philosophy will sooner or later discover, that these different views can be, although they're very different, they can be very tempting. So they're, the Kantian view can be very, I spend partly by my working time and free time just trying to understand better what Kant said, what Hegel said, just as a sort of amazing challenge to and sometimes I feel that they really hit, they really say something really great. But then, of course, can we really take that to today, and can we really make, use it? That's always another question. But anyway, here are some. I was talking fairly loosely and freely around the topic, but I hope it shows a little bit about this question of reality, and maybe Basil wants to say something about that as well.
Yeah, no, I don't want to add very much. I've always been very careful not to use the word reality, because I really don't know what it means.
Right. Yeah, if I could add, I remember David Bohm making a distinction along the lines that Basil's talking about between what is and reality. That reality was, at least at that point in time, it seemed to be a word that he was using in relation to, the appearance of thingness. Whereas what is was the larger question that remained elusive, perhaps. If I might add to my question, from what Basil was saying yesterday, I was struck by the echo of the indigenous thinking, the thinking of first peoples who see reality as relational. And it seems to me that you can make that notion of relation all the way down from consciousness to the subatomic level, and see that what is at least has something to do with relations rather than things.
Yeah, well, thank you, John. Hearing the word "what is" always reminds me of what David used to say to me quite often. Korzybski used to say, whatever you say it is, it isn't.
Right.
And the conversation would end.
Right.
Something more and something different. That's a typical saying also that, of course, with science, we had the idea of falsification is that science is as an enterprise is kind of uncertain in the sense that for many people, science doesn't really give us the truth, but it gives us still ideas that are justified. But then, of course, then we may try to falsify them. And in a way, what the Korzybski thing has to do with is that it's kind of saying that whatever we say, it is that typically our theories are both incomplete and probably incorrect. They're leaving something out, and then they may also be saying things that are not true. And so we should kind of be open to them before. And that's, of course, Popper. I mean, of course, Bohm and Popper were quite close, even friends at some stage. They would meet quite often and discuss. And I think Bohm was quite interested also in the notion of falsification, although he thought that, of course, it went too far and so on and so forth. But it's obviously this whole notion of testing our ideas, the whole notion of testability and all that is of course very crucial here, also with the question of reality. That if I want to make statements about reality, it would be nice if we could test them in some way or the other. I mean, that's of course a key part of science.
I remember he used to add that you build a particle accelerator based on a theory, and that allows you to if it's correct, your theory has some correctness to it, you're able to abstract something out that sort of matches your theory. But that doesn't mean you've actually understood what the basic nature of things is.
Right. No, I think there's limit. Of course, there are also questions: what are the limits of science, but and to what extent science can reveal reality to us, and I think I think Bohm is interesting in that sense, because on the one hand, he was if the Bohm's 52 papers were the first consistent version of that particular theory, then he is the person who in a way gave us what you might call the ontological or realist interpretation of quantum theory in a consistent way. I mean, of course, then there was the Everett theory and others that, but then again, he also problematized the whole notion of reality and in what sense does physics us a description of reality. But I think actually he had in one of the papers, he had some very nice thing. He said that everything is real in its context. So he would say that the atoms are real in a particle context, particle temperature, but if you take them inside a star, they are no longer atoms, they become mesonic transformations, which are then real in that context. So I kind of like that idea as a sort of I find that quite useful in even when, you know, discussing with philosophers, and that we should, because it's very easy in philosophy also deny reality of things. Just to say, well, it's just, you know, like, you know, it's, if you take any object, then it's in philosophy, it's easy to problematize it and deny and say, well, it's not real, and you know, it's just an appearance. It's, you know, the atoms are not real. It's the things that make up atoms that are real. And I actually liked very much. I thought that
beautiful.
That Bohm suggestion is a very cool suggestion, and it's sort of it's actually very useful.
Thank you so much, Sean, for this discussion. That was really, really interesting. And I think that we will be discussing this question even further in the second part of the Beyond Bohm series, which was mostly curated by Lee Nicol, who's really into the idea of holoflux. So we'll definitely be discussing more about this second part. We have another question, which is actually very interesting to ask you, as you both knew Bohm personally. Annette, would you like to ask that question, or would you like me to read it?
Oops. I can't find my.
We can hear you a bit.
Oh, could you? Oh, you know what? Go ahead and read it for me. You know, I can try.
It's quite, yeah, you're breaking out. I'll read it for you anyway. So the question is that, Pavo, you shared a very brief sentence comment about Bohm's relationship to religion, but then your sound blipped a little bit, so we couldn't really hear. Would you be able to say something a bit more about Bohm's relationship to religion, and if he himself was religious?
Well, I guess all of this is described, for example, in David Peat's biography, but as far as we know from there is that when he was younger, religion wasn't so important, and especially in the early years when he was more into socialism and communism and those things, then I think he felt religion is just it's a sociological phenomenon, that he didn't have any strong feelings like that. But then, as we know, then things sort of changed in the 50s. I think he got disillusioned when there were the Khrushchev revelations about what was going on in the Soviet Union. He got very disillusioned with communism, and I guess there was also like a crisis at the time in his life, which is, you know, it's described in the biography. And I think at that stage he then started to he had faith in science and communism, but I think then he feel that maybe that's not going to make people those things are not going to make people happy, even if they might work in a practical way. And he started reading things like Gurdjieff and Ouspensky. And Gurdjieff, I actually met somebody in Finland who is interested in Gurdjieff, and I think Gurdjieff, of course, is some sort of a Christian. Actually, there's a connection, the kind of Christian approach of theology or whatnot. But of course, then when Bohm came across Krishnamurti, that was for him a very, very powerful experience. And that was, I think that was probably his most important kind of what we might call religious contact in his life. Now, Krishnamurti was, of course, no ordinary religious teacher, or because he had a kind of, in a way, radical approaches of his own, because he was advocating know this and know that, although of course it was more complex, but still. So I guess it was then close to something like like Zen Buddhism or Advaita Vedanta. I think the people mention those kinds of things, that if you want to classify the approach. And of course, we know that Bohm also had discussions with the Dalai Lama and other. I think he became more generally interested in spirituality and even mysticism, and he had those discussions with Rene Weber, and it was sort of clearly that there was kind of religious dimension. And I remember once of course, because when I was doing my PhD in philosophy in Finland, which was kind of partly a fairly atheist environment, and so I don't know. Sometimes then I remember once Bohm and we went to Oxford for a seminar, and in driving in the car, I just took up the question, and I sort of raised the question about like what Nietzsche said, that God is dead, which is kind of just open up the conversation. And then Bohm says that it's not that God is dead, but it's more that human beings have kind of closed their minds from God. And now, of course, I don't think he meant it necessarily literally. I think he wanted whatever God means. I think he wanted to say that for him, that word meant something. It didn't mean a personal God. I think he actually wrote a review of Paul Davies' book, God and the New Physics, where he said that God need not be a personal God. I think he was kind of criticizing Paul Davies because he was kind of presupposing that it has to be just this more Western style of thing. So I think for Bohm, it was something more impersonal, but it was certain dimension that was important to him. And I thought it was interesting in the sense that I think he felt that the solutions to the world problems are not going to come from science alone or politics alone. I think there he was kind of following Krishnamurti. And I think he felt that some kind of spiritual dimension is required there, or we need some help from, like he was saying, God helps those who help themselves. It's not that whatever we call God would be there to solve all our problems. But I think he did feel that we do our best, and somehow there's some level of reality or some intelligence, perhaps he would call it, that might come into it and help us there. So I don't know, that's just a very brief, but those are a little bit of my impressions of what religion meant to Bohm. Of course, he would also say that religion is wholeness, that the word relegare, it can be coming together in a dialogue. It can be, you're coming together in a dialogue and you sense that in the group there's something larger than just a set of people, interacting. And that's something I think sociologists of religion see this as something interesting, that when people come together in a religious ceremony, then the togetherness itself may generate some sort of space or some kind of energy, which again may operate in us. So I think Bohm was interested in those. I think even in the dialogue experiments, he was interested in this dimension. It wasn't for him only an intellectual discussion or anything like that.
Thanks so much. That's kind of where I was going, because my sense is, and I don't know this in any way other than intuitively, but my family background is very similar, and so it wasn't about the dedicated religious practice of day-to-day observance, but more of the belief of wholeness and more of the belief that, like my mom would say, if she was a first grade teacher, and if people asked her what God was, she would say the answer to the unanswerable. And it was just this underpinning belief that something was there and connected, but not necessarily, even though her family was observant. I wasn't suggesting that Bohm was observant, but I was wondering how it influenced him and the wholeness. So thanks very much.
Thank you, Annette, for your question. Now, unfortunately, it's time So I'm really sorry for everyone who wanted to ask a question, but I guess we should start closing the session. I'm really sorry to all of you. Pavo, do you have any closing remarks you want to leave us with to close this week in this session?
Well, just I mean, thanks everybody for it. I think it's a great turnout. Thanks everybody for joining, and I hope somehow it was a bit of a mixture. I mean, there was a bit of a more personal recollections and then a bit more the sort of stuff we do in this more academic and philosophy. And I think it was quite a, well, we had a rich discussion here, and in some ways, of course, I think the whole issue of what Bohm's legacy for philosophy might be is there's still a lot to do there. I mean, I have some students and postdocs who are discussing these things a little bit, and there are other people all over scattered around who are paying attention, but I think it's still much more needs to be done, and hopefully we will be able to do those things in the not too distant future. And of course the PARI, who knows, maybe we should set up, especially when things get going with after Corona, whatever, maybe have a little meeting in PARI about focusing on the more philosophical ideas of Bohm, and also perhaps in relation to the different traditions, more this kind of more academic issues, which in some sense can be dry and sterile, but which Bohm did not stay away. I think he was very happy to also tackle those kinds of questions, and which do require a lot of rigor and a real deep interest in them. And so that side of Bohm is not that much studied, and hopefully we can continue this in the future. But anyway, thanks very much for everybody.
Thank you so much, Pavo, for that. And yes, let's do something in PARI about this. Yes, and also thank you, Basil, as well. You've done some very interesting contributions to this whole discussion. Thank you, everyone who have asked your questions. It's been really, really interesting in Q&A and discussion. Just before we go, I'd just like to invite you all to next week's closing panel discussion, which will be on Sunday, of the physics and metaphysics part of the Beyond Bohm series. In this panel discussion, we will have Emily Adlam, Basil Hiley, Shantina Sabadini, and Dave Strum, where they will be discussing the various topics that have emerged from the last 2 weeks. In this session, they'll be discussing amongst themselves in the first part of the session, but then they will be taking questions from you all. So make sure you've got questions ready because you'll be able to spark discussions. Again, to contact us, any problems or any questions you may have, you can use the website in the contact us section, or you can write to us on our social media, Facebook, Twitter, Instagram, YouTube, or just email us directly at james@paricenter.com to contact me, or eleanor@paricenter.com to contact Eleanor. Thank you all again for joining us, and we'll see you again soon here at the Party Center. Bye-bye.
Bye. Bye-bye.
Bye.